This is Professor Thompson again, working on problems from 4.4. This is number 20, and you can see I've already written a lot of the work I goofed up, so I'm restarting. So I'll just kind of go through the work I have here. So I'm going to go straight through the steps, just like the book does. The function is the square root of x squared plus x, then minus x, and the domain's only issue is when the square root is negative, so if that needs to be positive here, then if I factor that, you can see the zeros are at 0 and minus 1. So think about this parabola made because I have an x squared power. Well, it's smiling because the coefficient of x squared is positive, so it's this parabola here, and it's negative where the vertex is between minus 1 and 0. So that means I can stop at minus 1 and 0, and I can include those because the square root of 0 is 0. So I get this domain here. And then B is about x and y intercepts. You can see that when x is 0, you get y is 0. But you could have y 0 at other places. So if I set this equation equal to 0, I can add x to the other side, and then square both sides. But when I subtract x squared, I get that 0 is equal to x. So that's the only solution. From here, my next step is to do symmetry. There's no periodic symmetry, that's really for trig or functions. So I try to do even or odd symmetry, but if I plug in minus x, the square becomes x squared again, but then I'm stuck with this other minus x in the square root, and this other minus x outside, and it doesn't look like the same function, and it doesn't look like the negative of the original, so there's no symmetry. The last thing to do before we do derivatives is the asymptotes. But I don't have vertical asymptotes because that's when the limits are at infinity. So when the function's not defined, but then the limit is infinity. But the limits at the edge of the domain at minus 1 and 0, we already know those limits are 0. So I don't have vertical asymptotes. Horizontal asymptotes would happen at either infinity, so let's look at when x goes to infinity. And to figure that out, we have to multiply by the conjugate. So what I've done here is multiplied by the same expression with a plus over itself. And so you get that as the denominator, and then at the top, the square roots cancel, the middle terms cancel because it's a conjugate, and then I get an x squared and a minus x squared. So the top just becomes x, and at the bottom, I'm going to factor x squared out of both factors, so I have 1 plus 1 over x, but I factor x squared out, and then I take the square root of it to get this x. Now that everything has an x, I can factor x from the denominator, which I'll do on the next slide. So on the next slide, I factor that x out, and I can cancel those x's, and now I can take the limit, and whether this had been infinity or minus infinity, the 1 over x is going to go to 0, and you're going to get 1 over the square root of 1 plus 1. So that's 1/2. So that's my horizontal asymptote at either end. Now I'm ready to take the derivative, and so when I take the derivative here, I have to use the chain rule to start. I'm using the square root, so I have a half x squared plus x to the minus 1/2 power times 2x plus 1, and then x becomes 1 over here. So I need to simplify this, so that's really the first term is 2x plus 1 over 2 times the square root of x squared plus x, so that denominator over itself is what I'll make 1. And now that denominator is 2 square root of x squared plus x, and then I have this big numerator. Well, the bottom is 0, just like before when x is 0 or minus 1. And now I tried to solve the numerator set equal to 0, so I moved the square root over so that I could square both sides. And what I get here is I get 4x squared plus 4x is equal to 4x squared plus 4x plus 1. All that together means that 0 equals 1 if I cancel the 4x and the 4x squared. That's obviously not true, so that means the top has no solution when set equal to 0. So there are no critical values coming from the numerator. So I'm just using minus 1 and 0, and now I can make a sign chart, which is what I'll do on the next slide. So I go to minus 1 and stop, and then I don't go from minus 1 to 0 because that's not in my domain anyway. And then I go from 0 to infinity. So my test values will be minus 2 and 1, and then the top is all one big factor because it doesn't factor among itself. So what I do there is I'll just go plug in minus 2 to everything, so I have minus 4 plus 1 is minus 3, and then I'm subtracting this thing that has to be positive because of the square root. Square root only comes out with positive numbers. So I have a negative subtracting a positive, so that's going to be a negative. And then the square root, of course, and the next factor always has to be positive because I'm not plugging in at zeros. So this altogether is decreasing when I take a negative times a positive. I'm a bit out of space to write the column for f prime sign, but if I just multiply those two, clearly f prime is negative, and then I'm decreasing. Now when I plug in 1, I get 2 plus 1 is 3, minus 2 times the square root of 2. So that's okay to use your calculator here and just double check what that value is. And that value is 2.83, which is less than 3. So I take 3 minus something less than 3, and I get a positive. So that means I'm increasing here. But there's no local min because I'm switching at different points. I decrease to minus 1, I stop for an interval till 0, and then I increase. And we know at minus 1 and 0, the function is going to be 0 there. Or excuse me, at least at 0 it's going to be 0. Okay, so now we can take the second derivative. So the first derivative is 2x plus 1 minus 2 square root of x squared plus x over 2 square root of x squared plus x. So for the sake of time, I'm just going to show you the second derivative and simplify it without going through the work. So the second derivative here simplifies to minus 1 over 4 times x squared plus x now to the 3 halves. So the top is never 0, so again the only critical values are x is 0 or 1. Excuse me, minus 1. So now I'm going to make a sign chart again, but now I'm looking at this thing. So I go from minus infinity to minus 1, and then from 0 to infinity. Of course, this is a pretty boring sign chart now, because this is basically all just one big factor. So first I'll make my test value space here, and then I'm just looking at the sign of this, which is a little hard to break up. So I guess I'll use minus 2 and 1 again, and then that'll tell me f prime sign, which is the same as the sign of the factor, and then it'll tell me if f is concave up or concave down. Okay, so if I plug in minus 2, inside the 3 halves you get 4 minus 2, which is positive, times 4 is positive, and then you have the negative up top. So I'm concave down. And then if I use 1, this inside the 3 halves is 2, which is positive, to the 3 halves is positive, but then the negative up top makes it negative. So I'm concave down everywhere I'm defined. And I have no maxes or mins, so I also have to keep that in mind. And now we're ready to plot the function. So we know that 0, 0 is the xy intercept. And going back to the function for just a minute, it stops at minus 1. We should have also plugged in minus 1 and see where that's at. So minus 1 makes the square root 0, but then I subtract negative 1. So I guess I've got this point here. So let's see, after 0, we're supposed to be concave down and increasing, so this shape, towards minus 1 half, or positive 1 half was our horizontal asymptote. So something like that. Afterwards, we're supposed to be concave down and decreasing. And so I should look like this. And so the horizontal asymptote is only on the right side. And so I made a mistake earlier, so let me briefly mention that. If you have the square root of x squared, that's the absolute value of x. So that doesn't necessarily just cancel with x. So those are the things I canceled when I was doing my asymptote. That's okay if x is positive, but if x is negative, then it doesn't quite work out. And so that's why on the left side I did not get the horizontal asymptote, but I do on the right. So that's my mistake, but the final graph should look something like this.